ladies and gentlemen, welcome to you. So, dehydration synthesis is the topic of today. Before we get too much into the actual doing of an example here, what we have is we have dehydration synthesis here, and I want to go through what it means, what it says, that kind of thing. All right, so what ends up happening here first, the word synthesis. Anytime you see the word synthesis, I want you to think this. It means to make or to create something, okay? And what we're going to do is we are going to synthesize from one glycerol and 3 fatty acids. In a moment, we're going to make 1 lipid molecule, okay? Now, dehydration means just what do you think it means, right? So when somebody is dehydrated, it means we remove water, okay? So right now I'm right in your packets with you on the dehydration synthesis page. And so what we have is we have a glycerol molecule. This is a carbohydrate. And then we have 3 fatty acids that are right here. And what ends up happening is in order to join things together, as indicated by this plus, well, to make 1 molecule, what we have to do is we have to indeed remove a water. So what we do is this. What happened in nature is this hydroxide here and this hydrogen here would be removed, as would this one, and as would this one. Okay? So if everybody can see in purple what I've got here, 2 hydrogens and 1 oxygen, 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen, and what will happen is we're going to put those things together. And so what we're going to do is we're going to create a lipid molecule over here, okay? Now, this water is going to get pulled out, this water is going to get pulled out, and this water is going to get pulled out. That's why we're saying it's dehydrated, because those waters are going away. So the first thing I'm going to indicate over here is plus 3 H2Os, meaning 3 water molecules. And then what a lipid ends up looking like is everything that is left. And so we end up with here, carbon, carbon, carbon. This is the backbone of the glycerol molecule here. And then we bring over the things that were remaining. So we have a hydrogen, we have a hydrogen, a hydrogen, a hydrogen. And then over here, what would be left, right, is we would have an oxygen in the middle. So what would happen is, oh, and we can't forget this hydrogen right here, okay? We pulled out these items here. So what would happen is now this carbon is going to be bonded to that oxygen right there. So what ends up happening is we have an oxygen, we have an oxygen, and we have an oxygen. Again, right here, okay? And then the rest of the drawing is what you see here, okay? You have a carbon, double bonded oxygen, C15H31. So this thing would actually go like really long. Same thing here, we have a carbon with a double bonded oxygen, C15H31. We would have a carbon, double bonded oxygen, C15H31. And so what we went from is we went from having some monomers, some single things, glycerol, and 3 fatty acids, to making 1 large molecule that is a polymer. And again, this polymer is called a lipid. Now, one of the cool things about lipids, well, I've got your attention, right, is if you follow the carbons in a lipid, remember, this thing we keep going and going and going because it's C15H31. What ends up happening is if you follow the carbons along, carbon, 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 and then here, carbon, carbon, carbon with lipids, they end up looking like gigantic letter E's. And so there's your first one. That's the formation of a fat, otherwise known as a lipid. Okay, now let's take 2 amino acids and do a dehydration synthesis. Again, this is at the bottom of your page in your packet. So we have an amino acid here, 1. We have an amino acid here, 2. These are monomers, single items that we want to join together and make a polymer out of, more than 1. So again, in order to make something, and what we're going to make over here is we're going to make a substance commonly referred to or known as a protein. Multiple amino acids coming together makes a protein. What we're going to make is we're going to make a protein by removing water. And so what we're going to do is, if you look right here, you have this hydroxide and that hydrogen right there. And what would happen is that is going to get pulled out. And so, just like before, what we do, the first thing is we indicate just that, our one water molecule that we're going to take out of the reaction. And then everything else just comes along. So what ends up happening is we have a hydrogen bonded to a nitrogen, that's bonded to a carbon, and that's bonded to another carbon. And we're going to shift that double oxygen to go upward now, and here's why. What we need to do is we now need to join together this carbon to this nitrogen here. So what ends up happening is we end up with nitrogen here. Can't forget the hydrogen, that was this hydrogen right there, okay? And then what ends up happening is we have a carbon, it's still double bonded to oxygen, and it's got an OH right here, okay? And so this substance that we have right here that we have created via a dehydration synthesis is called a protein. 2 amino acids to make 1 protein. And again, why did we do it? We take out water, and when we do that, we create bonds, okay? We created that bond right there by removing and taking out of water. And this is called a dehydration synthesis. Now, the type of bond here, okay, gets a name, and it's called a peptide bond, okay? Because amino acids bond together to make proteins by amino acids, or by peptide bonds. So that's the dehydration synthesis and the creation of a protein.